Howdy everybody in YouTube land. What we have in front of us today is a small Sony Trinitron. This one is the KV-8100. Now, I've never had one of these sets, but I remember when I was at VCF East, I saw one of those in consignment and I really kind of wanted it. And I remember there was one of these in there and it didn't have a price tag on it. There was two of these, I think. There was another one that had a price tag for like 60 bucks or something. And then there was another one that didn't have a price tag on it, and it was small, and I was intrigued. It's like a consumer version of the PVM type displays, BVM displays. Anyway, so this one popped up on eBay, and it was kind of pricey because, well, the Trinitron meme, it's like desirable because of retro gaming. But anyway, so this thing was on eBay. It was kind of expensive. I remember clicked on it and then I clicked away from it. And a few days gone by, and then the seller actually sent me a random offer for this thing. So with the random offer for being like 30 bucks, I think it was, I was like, you know what? Why not? So I bought it, and here it is. It does come with the cables. So we have the AC cable, which is good because it's a weird proprietary type form factor there. So we have the original power cable, and then we also have this specialized, well, that's not original because someone, yeah, that is not original. And also we got these free little tags here. See, no, this is like from an antique store. These are antique store consignment tags. That's what this looks like. So somehow this ended up in the same box that this TV set is in. That's garbage. So apparently this thing doesn't work. It doesn't turn on, or there's something up with it. One thing I noticed right away is the antenna is busted completely off. And that's one of those little ball style antennas and not a slotted, so they're not as commonly available. Not like there's anything OTA anyways that this could even be used for, but it would be kind of cool if that was properly repaired, which I think I can get universal ones of those on eBay, but I'm not sure. Otherwise, there's a little bit of wear. There's some pry marks at the top, which I don't, someone's been in here. I don't know what's going on with it. I'm afraid to plug it in to see, just to kind of juice it up and see what's going on, but seems like the seller already did, so why not? So here's an interesting observation. We have battery 24 volts, center negative, typical freaking Sony. We have DC 12 volt input, and we have AC input. So I'm curious. Oh, this is fun. Look at this. The RF, this is an RF only set. There's no RCA jacks on here. And the RF goes through this funky little 3.5 millimeter jack. So looks like we have a side cover here, which looks to be potentially broken. And if not, it will be. Let's try to get in here the right way around. Ugh. Oh yeah, it's definitely broken. Someone velcroed the crap out of it. It's classy. I'll give them that much. What's in here? Also broken. Oh yeah. That's how you set the tuner fine tuning. It's a Varictor tuner. That makes a lot of sense. Alright, well, now is a gooder time than never. So they say this doesn't work, which is probably why the seller sent me an offer on it, because it was cheap. Because they likely have not, they haven't gotten any bites on it. But anyways, let's see here. like the way that clicks. Alright, what happens? Dead. Absolutely nothing. Alright, well, I could probably print a new tab for this with the 3D printer, but I don't like the way that thing clicks though. It doesn't seem right. I'm wondering if that's an interlock in here. Let's see. No. Alright. So we know it's not working properly on AC input. So this one's labeled. So here's what I think I want to do. Set this up for 12 volts. Let's follow this pin diagram. See if it draws current from the 12 volt input. If I can get the alligator crocodile clip in here. No power. Alright, so the TV is definitely dead. So we got to pop this guy apart and we got to see what is going on in this set. There is something up with it. So let's investigate. Got the cover off and I can tell she's got some hours on her. A little bit dirty. You can tell someone's been in here cleaning too because you can see the white marks on the anode cap where someone has definitely been tinkering. Now, one thing that is apparent is we have a regulator transistor here, which we could test that because we don't have any power. So if I were to surmise a guess, we've got a blown fuse somewhere. Now we got to get down to the bottom of why that is. I could be wrong, but I have a suspicion. One thing I did notice apparent right away, that is the deflection board, which includes the horizontal output transistor. It has a separate deflection transformer. You can kind of see it in there. It's right down in here. So that means, and then the flyback's on the bottom. So that means this is a split horizontal set, which is a little bit more complicated. So the horizontal deflection has its own deflection path, has its own drive transformer, output transformer, and then a horizontal, impedance matching deflection transformer. And then the flyback circuit is separate, because I bet if I tip this over, what do we have in here? Yeah, there it is. The high voltage flyback circuit is a separate path than the deflection circuit. So we need to figure out what we got going on here, why it's dead. So I think there's two things we can do here. We can check this regulator transistor to see if it's shorted. And if not, we can probably take the two screws out and swing this board out of the way because I can see nylon hinges here. So that's what we'll do. We'll check this guy real quick first, and then we'll swing this board out of the way so we can just see kind of what's going on. Oh yeah, she definitely has some hours on her. Look at that. Look at that. There's the deflection transformer over here. Not sure what this one's doing yet. But, oh, that's a cool little diode pack. But yeah, I mean, look. Looks like it's got a tripler focus block. Yeah, with how small that flyback transformer is, that's a tripler. But yeah, we've got that. We've got... Man, we've got all kinds of stuff going on in here. A complicated little set. But, alright, let's start testing some things. Alright, so the regulator transistor tested fine, and the horizontal output transistor on that board tested fine, so I flipped it over so we can look at the flyback side. I don't know where the output transistor is on this side yet. I don't know if it's like buried in here somewhere, because on the bottom side I can't really see anything that would look like an output transformer. I did, however, see this bridge rectifier arrangement. We have AC and we have switch. So I'm thinking it goes through here and switching comes back across this fuse. Now, I did just meter that fuse and it's open. So the fuse is blown. What I don't know is why. And I checked all 4 of these diodes real quick. And it is not, those diodes are not shorted. So, yeah. That's a fun thing to get out. Yeah. Oh, yeah, the high voltage wire's in the way. So, does this not have a horizontal output transformer? Or transistor? Transformer. Transistor? Maybe not. Let's see, 1847, 120. That's strange, but okay. I might have to pull a service manual for this thing. Oh, yeah. Pulled the fuse, and something serious happened to this guy. Usually fuses don't go that black unless there's a hard short. And I had to get this thing off of its board support carriers to move it out of the way. And I had to unplug that because the fuse is just sitting right here. Pulled it, and it's blown wide open. I'm not just going to shove a fuse in there, because a fuse that looks like that, where the whole thing is just vaporized, is a hard short. So something catastrophic happened with this thing. The question is going to be finding out what. And actually, matter of fact, there's a resistor right there. Looks like it's gotten a little toasty. That might be normal. But something for certain happened with this, and I can see some debris in there from bugs where it was left out. I wonder if this became like a garage TV or something. I checked that 2235 volt and it's fine. So that is not why. But we do have a bunch of these blue Panasonic caps in here. So I don't know. Something catastrophic happened to it though. Hopefully it's not like this tripler Focus G2 block going bad, because if that's bad, that's fatal. This is scrap, but hopefully that's not what it is. I've been trying to study this power supply circuit in the Sony Trinitron here, and it's very, very strange. I've not seen anything quite like this. So the way this works is we have a power transformer. Since this has multiple forms of input power, it's got to accommodate for all of them. So we have a power transformer, input, rectifier, goes out to the switch, comes back, goes to the fuse. This fuse is blown. And then it comes in over into this voltage regulator, which is this transistor over here, the one that we tested. So it gives us 22 volts that runs the set. That's all fine and dandy. But remember, we can do external 24 volts from the battery plus 12 volts. How does that work? Well, if we take a scroll down here, we have our power input. AC in, goes to the transformer, the power switch, all that, and goes off to the rectifier. But also, we have the 12 volts input, which goes through, comes around pin 55, which feeds through here, and all of this circuitry over there. So this, I'm not sure what this does. Maybe this charges the battery and it's part of the regulator for that. But then we have a boost converter over here, which takes the 12 volts coming in, like from a car charger, and boosts it up to the 24 volts that needs to run the set. So they use a switching converter to boost it up, and then a linear regulator to take it back down. Whatever. This was the 80s, you know. So that's how they did that. But what's even more strange is the frequency drive for the boost converter, if we follow it, goes all the way back to the horizontal drive. So they're using the line frequency to sync this circuit up. So I don't know if that's for noise reasons or what, but that's how this circuit works. Is we got 12 volts. If we run 24 volts straight in here, we're going 55 into this regulator ordeal, but it's also coming out and through this switch and back up into the linear regulator right in this point here, these two right there. Now the ground is fed through this switch, which is pin 50, because we have the fuse. Everything goes to this fuse because the switch goes to the switch out here, but it comes back from the bridge as well as pin 50, which is right here. And there's our ground point. Common. So DC input common here, battery common input there, goes through pin 50. So in order to bypass the fuse, we can connect it straight to chassis ground. But that fuse has been blown catastrophically. We don't know why. It could be the boost converter shorted out. It could be something wrong down here. It could be a lot of things. So I think to rule out the entire rest of the set, what I want to do is I want to take this transformer connection completely off. And I want to potentially, because this is the power switch, I'm going to ground it straight to ground to bypass the fuse. And I'm going to come in here with my DC power supply with the current limiting turned on. That way I can rule out the rest of the TV circuitry. So if the rest of the TV comes on and works off of the 24 volts input, that essentially rules out the television. Everything works fine there. So we can focus our efforts in the power supply section instead of the whole TV. So let's isolate everything upstream by testing it first. So that's what we're going to do. And it's either going to work or it's going to blow up into a ball of flames. So that is what we're going to do. So we're going to come in right here with the transformer. So I'm going to disconnect you. This goes right into the bridge rectifier. The other thing I want to do is come in right here where the power switch is and take it to chassis ground. And that will tell us if the power supply circuit is going to work properly, or well, not the power supply circuit, but the rest of the TV. God, this does not want to come out. That's because I can't get a grip on it. There we go. So there we go. That's how we're going to do that. So that way, we know if everything works fine. Now, you can't do this with 12 volts. It won't work because this goes around the boost converter. So this basically just eliminates the need of the boost converter. So we're going to go up to 24 volts. Turn this, well, the switch doesn't matter. So we're going to go up to 24 volts. And we're going to bring the current down a little bit. This may or may not work. We're going to do this hot on camera. Don't try this at home, folks, unless you really know what you're doing. In this case, I don't. I pretend like I do. So let's see. What do we get? Well, I just heard the TV come on. I think it's running. But I have no picture. So I hear the high voltage. The high voltage is on. But there's no picture. So there's definitely some issues going on here. Alright. So that rules out the high voltage deflection stage. It is on. But we don't have any picture. So let's see. Disconnect view. Well, none of that's on. None of this has power. So we have some serious issues. That's why the fuse blew. So we're missing a rail voltage somewhere. Because this does not have power. Alright. Hey, we're getting closer. We're getting closer. So when that fuse blew, that was the result of something else going. Now that I've re-energized the set, what we've learned is the deflection circuitry is on, but this other stuff isn't. So we need to go back to the schematic and find out where that comes from. Alright. We have all of that coming from there. There's 12 volts. So we have a dedicated 12 volt supply. Where is that dedicated 12 volt supply coming from? I think that's what we have here. So we have, there's our 22 volt supply, which is working, which is why we have deflection. 12 volt regulator. Here we go. So this is coming from... So that's what we need to check. We need to check to see if our 12 volt supply is present. Because that seems to be powering a lot of here. You see these resistors? The reason why there's a square around them is because these are fusible flame-proof resistors. Which means when these fail, they fail silently and invisibly. And they usually fail if there's a catastrophic failure in the circuit. So, if we follow this, it is coming off of the flyback transformer. So, we have some probulating to do. Yes, that's what we're going to do. We're going to check Q801. We're going to check all of that. We need to make sure we have our 12 volt supply. Because without that, this stuff's not going to light up. Right, so we are energized. Let's check some quick voltages here. 22 volts, which should be good. A little low, but we're good. 47 volts. A little low, still we're good. 18 volts, and we're good. Now here's Q801, which if we look is that 12 volt regulator. So let's take a look at the collector of Q801, which is here. Would you look at that? Oh, there's no voltage. All right, let's look on the other side of R813. Still no voltage. Okay, now that means we need to take a look at D803, which there's another fusible resistor there. R803. So D803, where are you? We need to follow you. D80, there's D803. So if we look at D803 here, nothing. So that tells me we have an open R803, which is going to this ABL or 15 volt signal. Alright, so R801 is going to D801, which is a negative signal. So let's take a look at D801 and make sure it's present. So R801 goes to L801. And then we have D801. So if we look at this test point here, minus 24 volts. So we're good. Now I bet, I'm going to cut the power here, shut all that off. I bet R803 is open. Now the next question is, why is it open? That it could explain why the fuse blew, because it saw a big current spike when all of this failed, which popped this fuse. Now that I energized it back up with the DC voltage, it probably opened that resistor because it forced itself on, right? At least I'm assuming. I'm making a lot of assumptions here. But it's funny. I had a funny feeling that 12 volts was missing because we're like missing half of our signals and we have no picture. All of that is run off the low voltage rail. So let's do some tests here and find out what we got going on. Alright, so now that we know we have a problem with the 12 volt rail, it's time to figure out what we have going on here. So here's what we're going to do. Let's see, we're going to measure some resistance charts. So let me pull up the schematic real quick. We have D803 an R803 coming off the flyback transformer, which is blah, 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 D803 right here. Well, 0.0234, that's almost a short. Let's see, R813 over on the Q801 side, which is a fusible resistor, 4.7 ohms. 280, so it's higher over here. So I don't think we have a short on the Q801 side, at least I don't think so. It's kind of 272, 226. So yeah, the short is not on the regulator side. So if we look on the diode, do we have a short at the diode? No. Well, that leaves C803, which is a 470 at 16 volt. I mean, that's the only thing that I can see being a problem. So I'm going to warm up the desoldering iron so we can pull that out. But, so that goes back to R803, which is the fusible resistor. It's a 1.2 ohm. Yeah, that's pretty open in my opinion. So let's just do ground. Yeah, it's pretty open. Yeah, it's dead. Alright, so R803 went open because I guarantee you C803 is shorted. I don't know if that's the only problem yet, but that's why we're missing our 12 volts. Now, it's possible that this capacitor was shorted when it was someone attempted to power it up, and that's what blew the fuse, because there was just such a current surge. And then when I went to power it up, it probably opened the resistor. I don't know, but let me do what I think is the problem. And pull the cap. Alright, cap fell out. Let's see, does the short remain? Yeah, it does. Alright, well, I was wrong. The capacitor is not shorted. Something is, though. Let's see, what else could it be? Okay, we have a 220 ohm resistor to a Zener diode to ground, D806. So the 220 ohm resistor would make sense. So let's see, let's find out. 220 ohm resistor here. Let's see. 28 ohm. No, that's no. There's no way that's accurate. 28 ohm. Ooh, you know what? Hold on. Yeah, that's not right. So we have C813. So let's check C813. There's a lot of things to check here. So C813, where are you? Actually, let's just go ground to emitter. It's shorted. So we have a short from ground to the emitter. Oh man, that could be anywhere. So ground to the emitter is shorted. Ground to the collector is not. So it wasn't the cap here, like I thought it was. No, the ground to the emitter is shorted. And the emitter is the 12 volt output that goes to the rest of the circuit. So, okay, we have a short. It's not even, let's like to see, what is it? So from ground to the emitter, it's 1 ohm. There's literally a direct short. That will blow the fuse. That will fry the resistor. So the question is, why is that there? We have R814. Not sure. Okay, that's the 27 ohm 1 watt. That makes sense. That's why I've got that reading. So that makes sense because we have a short to ground. So C813 could be shorted. Well, that's a path of least resistance. So let's see. C813. Let's check you. Where are you? If C813 isn't shorted, then we've got a bad semiconductor in the circuit. There's C814. C813 right here. Okay? Let's pull C813. I don't want to pull the whole thing. I just want to... Nope. C813 is fine. I bet if it's charged. Yeah. C813 is fine. Okay. That's not good. That means the fault is upstream on the regulator. Let's check base to ground, because there is a diode there. Let's see. Base to ground. Base to ground. Well, that's kind of interesting too, but yeah, something's definitely going on there. But here's the problem. Here is the problem. That 12 volt supply runs a ton of stuff. So that short could literally be anywhere. Oh, this got a lot more complicated than I thought it was going to be. Here I thought it was C803. That is not the case. It is not C813. It is likely not Q801 because there's no direct path from there to ground. So what could it be? That is a really good question. I think what we need to do is we need to separate. Let me just unplug all this because this doesn't matter anymore. We know what our problem is. We have a shorted 12 volt rail. So this one's going to be a fun one to repair. I love it. It's cool because we finally got a good one to troubleshoot from scratch here. So, alright, so this is A10. So there's gonna be plugs that go to the other board, and I need to separate the two boards to make sure that we don't have a short somewhere else, because there's that transistor. There's the little 470 at 16 volt cap. It's fine, but now that I sucked it off, I'm going to just replace it anyways. But we have, this is that transistor. I don't know if you can see it, but it's down here. Okay, there's a fusible resistor that's been blown open. So let me unplug some plugs to see if the short goes away. So I'm just going to find a probing point to ground. Because its chassis ground is the same ground potential as everything else. So I'm just going to do that, I think. And then we're going to go... So the ground 12 volt supply is right here. No, so it's not there. That's not the short. So somewhere on this board, because we have, God, we've got so many wires going to so many different directions. Let me check you up here. And you up here. My phone is going nuts because it always does. Hey, how about that? The short is gone. Alright, let's see. Which plug is it? A9? Nope, it's not A9. What about A11? A11. So A11 is shorted. Time to figure out where that goes. Alright, so let's figure that out. Alright, so here's A11. And there's our 12 volt wire right there. And if we remove this plug, it goes away. So if we chase, let's see, it goes to 12 volts in this circuit right here, which is the tuner board. No, what is this circuit? What is this circuit? Hang on. We have, let's see, because there could be a couple places here, because hang on, there's 12 volts, which loops itself right back out to this freaking AGC garbage. So it could be there, or because it goes to a bunch of different places. This short could literally be anywhere. So I think I'm gonna continue on unplugging modules. Automatic fine tune. So this is all tuner circuitry. Oh, there's another 12 volt right here too. Hue, brightness. Although that 12 volt is coming from a different spot. Because yes, there is a 12 volt here, but I don't see any ties. 12 volt, 12 volt. It's one of these ICs, could be bad. There's a meter indicator. So yeah, this little circuit board here, I think is right here. This is that board. So somewhere in here is a short. Now what I'm going to do is, first off, let's find this connector here, this AGC connector, and unplug it and see if the short goes away. Because there's a 12 volt wire literally right here. Because if we unplug that and the short remains, we know without a doubt it's on this board. So let's do that. Alright, so the way we're going to get to the 12 volts going to the AGC, that is this module here. 12 volts is on pin 7. So if I go to this module and I check pin 7, which I'm sure is right here. Hold on, where's the 12 volts? 7. Yeah, it's shorted. Alright, so now we unplug you to make sure our fault is not on this module. Now there's no grounds anymore, so I gotta check the VCC back down here again. And it's still shorted. So it's not in the AGC module. That means our fault is in this module here. This module's bad. Now, unfortunately, most of those that are on the 12 volt supply are IC chips. Finding the IC, if it's a bad IC, we've got a serious problem. Because these ICs, I'm pretty sure, are ASICs. Because I see some digital information. Yeah, there's some digital microcontroller stuff off the 12 volt supply. Yeah, I'm looking at the schematic now, and we have 12 volts coming in. We have, well, let's see, the microcontroller has, well, let's see, IC002. I don't see a power rail. No, actually we do, 12 volts. Power on, 12 volts. Yeah, that's coming from a little Zener regulator. So, well, I doubt it's an IC then, because the ICs are all being powered from this Zener regulator. VCC. Oh, no, never mind. IC004 is connected right off the raw 12 volts. So we've got some issues on this board we have to chase. That's going to be fun. So I got to get this thing apart and out of here so I can look at it better. Well, that was fun to liberate, but our problem is in this board somewhere. It's going to be some gymnastics to find out where. I want to make sure something didn't get cracked or broken, because this is a user interface board, so I doubt it, though. Not good. Not good at all, but this is our bad board. It's in here somewhere. Fun times. Alright, after studying this circuit, unfortunately it looks like one of these ICs are bad, so at this point, from this point forward, it's just going to be entertainment purposes, because there is no fixing this set. Now, we can figure out which one went bad a few different ways. We can pull the IC out, or we can remove the inductors that are in series so we can isolate down which one went bad. So we can do that, because, well, if I remove it here and the short stays up here and goes away, then we know it's in this IC, which is the microcontroller. Or if it still stays over here, then we can remove this inductor, which will tell us if it's in this chain. Or we can remove this inductor, which will tell us if it's in... There's a lot of things we can do here. So, yeah. Alright, well, I did some measurements of the inductors, and the inductors have some resistance. Not very much, but have some. So this controller IC is not at fault. So our lowest resistance is at one of these 2 points here, either IC4 or IC5. Or no, 3 I mean. So I'm going to pull off IC4 first and see if the fault is in there. Otherwise it's in IC3. One of those two is bad. Alright, so I decided to take a different approach. Just bear with me for a second. So what I've done, instead of starting pulling ICs, I said, you know what? I got my power supply set for 2 volts, constant current mode. We know the short is on this side because I measured, you know. And just to go through it on camera with y'all, I'm going to put the probe here. And if I start on this end, 0.0023, and then on this side of the inductor, it's 0.17, but if we follow that down, it's 0.17, and then on this side, it's 0.5. Which is connected to these 2 ICs. So our problem is with those 2 ICs. But before I start sucking off ICs, what I did was, I got my power supply set up. Pin 5 is our VCC in. So notice it's pulling an insane amount of current, because I'm trying to energize it. Which means something is going to get hot. So I'm feeling around. ICs aren't getting... Wow! Ow, ow, ow. Oh, yeah. Hold on. Oh. That 100 microfarad 16 volt cap is getting roasting hot. Really? So I was right. It is a shorted capacitor. Just not the one I was thinking of. Oh, man. That is C056? C05, no. I don't know, C057, well, let's see. Let's look at the schematic, shall we? Yeah, 100 UF 16 volt. C057. Alright. Let's, so we're gonna remove this capacitor. Still hot. Alright. Okay. No signs of leakage. Okay, let's see. Did the short disappear? Let's find out. Ground. Back to here again. Gone. No more short. Wow. Wow. A capacitor did short. You know, people say don't blame the capacitors for everything, and I really tried not to blame the capacitors here. I was thinking maybe the ICs were bad, but sure enough, it was a capacitor, and it's not leaking either. So let me check it. Shorted. Yeah, that sucker right there. That is a 100 mic, 16 volts, Panasonic. Shorted. That one capacitor caused this whole nightmare. That one cap. So right here, C507 was shorted. 100 microfarad at 16 volts. Just out of all the caps in the entire circuit, that's the one that shorts. That is the one that shorts. And it's not showing any signs of leakage either. It's just shorted. So, yep. There you go. There's why. So I got to find a resistor for the regulator circuit. I got the caps. I got to see if I have a fuse. In theory, it should work. That one capacitor. You know, while I have this out, I'm going to spray these potentiometers too, because why not? Alright. Now, we have all the components we need. Now, I do not have a fusible resistor. So, if this resistor goes bad, you're going to know it. That's for sure. You won't miss it. I promise you that. It'll be like a reefa. Anyway, so let's see. I think the negative goes here. Moment of truth. Does the DC-DC converter work? Well, step one. Okay, we're good there. Step two. It does. The DC-DC converter works. Yes, we're good. We're good. We're good. We have a good DC-DC converter. However, we have a bad vertical output stage, so we still have more work to do. Still more work to do. Not surprised. So, where's the vertical output? Well, it's right here. And if we look, we probably have... Well, I got a stake in here. Remember how I said that's the spot that looks like it saw the most heat? Well, it's come back to haunt us now, hasn't it? So, one of these 4, 5, if not all 5 of those capacitors are bad. Which ones? Well, we don't know. We got to check them. So, because there's our vertical output transistors right there. Then we have the oscillator, driver, all that stuff. So what do we have? We have a ITT Tech 4.7 mic and 160 volt, which I probably don't have. That looks like it's in the yoke circuit. We have a 220 UF 16 volt, which I do have. And then we have 33 at 16, which I have. And 33 at 25, which I have. So, oh, we got another one over here. So we have 6 of these caps. So one of these is bad. So let's figure out which one it is. I'm going to start looking at the schematic real quick, and then we can actually grab our meter and see. Actually, it was just the vertical hold that was way off, but the signal's really crappy because I've got this, you know, crazy little setup with jumper leads. But other than that, it's actually working. I don't know if the color looks... I don't want the color too bright. It needs to be something like that. Yeah, it's a picture control. Yeah, I'm turning it down so it looks better in the camera. Something like that. Trying to get the tint just right. About like that, I think. Yeah, that looks pretty good. It's actually working. There we go. Audio works. Wow, it's actually working. I am impressed. It's impressive. Picture's not clear because, well, we've got an issue with the antenna. But you know what? That's working amazingly well. Wow. Alright, so now that we know that the 12 volt input works, I want to test a couple of things. I just slipped the back on right now because we're going to test the antenna input just to make sure it comes in super clear. And then we're going to test the 120 volt input. So, here we go. Seems to work fine. And you see how it comes up green? Really, really green, and then it gets better. So that tells me we actually have some issues going on with the CRT. It's weak. But hey, it's coming in clear now. Let me just run JL2 real quick. So anyways, everything looks to be good so far. Audio works. But I'm going to keep that muted because this stuff is starting to get trigger copyright filters now. Anyway, so it seems to be working okay. Besides that, it looks like we've got, it's hard to see in camera. I'll turn the brightness down. But we've got a little bit of splotching going on here in the aperture grill, which is common for Trinitrons if they get jostled really hard. Because there's a little wire in there that holds it together, but this section's bent a little bit. And there's no fix for that except to replace the picture tube. And you can kind of see the spot right there. And I tried to degauss it out earlier, but it doesn't actually work. But anyways, the other thing it has is it has a weak CRT, because look what it does. It gets blooming when you turn the brightness up. Which most CRTs will do that naturally anyways. But the key difference that sets apart one that does it due to poor HV regulation versus one that has got a weak CRT is the brightness. Now, the camera is auto-compensating, but this, when I turn the brightness up, it's going to bloom a little, but it should be getting blindingly bright, but it is not. The brightness just kind of stops, and it just gets more and more muddy. So that's a weak picture tube, which tracks because of how many hours it looks like it's on it. So anyways, what I thought was a vertical fold-over syndrome was not what it was. It was the vertical hold was a bit off. So once I tweaked that, it was fine. But anyways, other than that, the TV appears to be working perfectly fine. So we're good. All it was, all in all, is we had the 100 microfarad capacitor shorted, which popped the fuse, and it burnt this resistor. I don't know the order of how this happened. The fuse was probably already blown, but when I energized it externally, it's possible it opened up the resistor here. But the issue is that resistor looks burnt. So that would have let off smoke. And I did not see smoke. It just didn't work. So this happened on someone else. It was probably smoking, and it burnt that and blew the fuse at the same time. So anyways, that's all it was. Everything appears to be working. Now, I can get a replacement picture tube. The only problem is the only ones that I can buy now are the more modern ones. It supposedly will sub in here, but it's a more modern one that has a finer dot pitch and a darker, more contrast phosphor, which is what you see in the later 90s versions of these, and especially the broadcast video monitors that are 8-inch, like the 8042s, PVM 8042, stuff like that. Use the newer style tube that's in this form factor. I cannot get this particular one. So if I replace this picture tube, it's going to look like a PVM 8042 at that point. But, I mean, all in all, it is watchable. Will it last? I don't know. But as often as I'm going to use this thing, it's not going to matter so much, I don't think. So, anyways, that was pretty much it. So there we go. We had a look at and a troubleshoot and repair of a Sony KV-8100 Trinitron. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.